Hello, this video is on section 6.3, which is titled Binomial Radical Expressions. And the learning target for this one is to add, subtract, multiply, and divide radical expressions. The first two lines here that I've written in purple are basically the only two formulas you'll need. If you have a times the nth root of an x plus b times the nth root of an x, you can then take the coefficients of each of your radicals and add them together with the one like term of your radical in the index. The same exact thing can happen if you have the common like term of the nth root of x in both of these and a minus between them, so you take the coefficients and you subtract them. This only works if both your indexes are the same and both everything underneath the radical is the same. So the first example down here, we have an index of 2 in both of our radicals, and our radicand is both 5x, so we can combine these together to equal 3 minus 2 radical 5x, and 3 minus 2 is equal to 1. Or we can just write our answer as the square root of 5x. Combining everything together, 3 minus 2 is 1. The like terms are square root of 5x. Second example, we have 6x squared radical 7 plus 4x radical 5. We have an index of 2 in both of these, but our radicands are 7 and 5. They are different. Since these are not the same, we cannot combine them, so our answer is simply does not simplify. Then the last one, 12 cubed root of 7xy minus 8 fifth root of 7xy. This is a 5, this is a 3. Since my indexes are different, these also cannot be simplified. So only if both your index and the radicand are the same can you combine everything together into like terms. If they are not the same, then you leave your answer exactly how it is and it cannot be simplified. Okay? Sometimes if we have differing numbers underneath our radicand, we are able to simplify them and factor out numbers from each of the radicands. So if we look at our 12 and we factor out the largest perfect square, we get the square root of 4 times the square root of 3. 4 is my perfect square, and 4 and 3 are both factors of 12. Then looking at 75, my largest perfect square is 25, and I'm left with the square root of 3. And I cannot factor the square root of 3 anymore, so I'm going to keep it minus the square root of 3. The square root of 4 reduces to 2, and I keep my radical 3 the same, and my square root of 25 reduces to 5. Since I have equal indexes on all of my radicals and the same radicands of 3, I can combine them to get 2 plus 5 minus 1. 2 plus 5 is 7, minus 1 is 6. So we have an answer of 6 square root of 3. This is the most simplified answer to the expression square root of 12 plus square root of 75 minus square root of 3. Same exact thing down here with the cube root of 250. The largest perfect cube, from 250 is 125. And the other multiple of 125 is 2. Since 125 times 2 is 250, these are both factors, and the perfect cube is 125. Factoring 54, the perfect cube is 27, and the other factor is 2. Then factoring 16, we get the cube root of 8 times the cube root of 2, which is left over. Okay, the cube root of 125 is equal to 5. The cube root of 27 is equal to 3. And the cube root of 8 is equal to 2. Since all of my indexes are 3 and all of my radicands are 2, I can now combine the coefficients. 5 plus 3 is 8, minus 2 is 6. So my answer is 6 cube root of 2. 6 times the cube root of 2. So only if we have equal indexes and equal numbers underneath our radical can we combine them. From the start, we had to factor out and see what we can cancel and simplify. This next one, we have a binomial expression being multiplied with another binomial expression. So what we have to do is FOIL them out. The first two being multiplied, 4 times 5 is 20. The outsides, 4 times 4 square root of 2 is 16 square root of 2. You multiply the coefficients and you leave your radical exactly how it is. Then to multiply the inside, 5 times 2 square root of 2 is 10 square root of 2. And then the last is 2 times 4 is 8. Square root of 2 times the square root of 2 is the square root of 4. So you're multiplying everything, no matter what it is, underneath the radical or not, together. These two terms can be combined since I have equal numbers under the radicand. 16 plus 10 is 26 square root of 2. And then the square root of 4 reduces to the number 2. I then multiply these out to get 20 plus 26 square root of 2 plus 16. And these numbers can be combined. 20 and 16 add up to equal 36 plus 26 square root of 2. And this is the most simplified solution to that expression. So multiplying everything together, no matter it's radical or not, you get this first line. Combine everything that's like terms and simplify the square root of 4. From there, you just simplify down to get the least complex answer or the most simplified answer. Okay, now looking at ones with the fraction. We have a square root of 5 minus the square root of 2 in the denominator. So in order to get rid of our radicals in the bottom, we must multiply by the conjugate, which is the square root of 5 plus the square root of 2. Just a reminder, the conjugate is whatever you see in the denominator, but the opposite sign separating the addition or subtraction. So since we see subtract, we multiply by plus on both the top and the bottom. Okay, so 3 square root of 2 times the square root of 5 is 3 square roots of 10. 3 square root of 2 times the square root of 2 is 3 square roots of 4, and that is my numerator. Then foiling the bottom, square root of 5 times the square root of 5 is the square root of 25. Outside is positive square root of 10, 5 times 2 underneath the radical. Inside, negative square root of 2 times square root of 5 is negative square root of 10. And last, negative square root of 2 times positive square root of 2 is negative square roots of 4. All right, the square root of 4 in my numerator reduces to the number 2. And my denominator, the square root of 5 reduces to, square root of 25 is 5. These square roots of 10, positive and minus, cancel out. And the negative square root of 4 is negative 2. 3 times 2 is 6. So we have 3 square roots of 10 plus 6. And the denominator 5 minus 2 is 3. From here, you can factor out a 3 from the first term and the second term. So we are left with the square root of 10 plus 2 divided by 3. Then from here, my 3's cancel out on top and the bottom. And that is my solution. The square root of 10 plus 2 is the most simplified solution to this expression. So in conclusion, you want to take your radicals, simplify them as much as possible, see what you can cancel out, see what you can factor, and simplifying everything down. These are not equations, these are expressions. So we are not subtracting from one thing to another. You're just looking at what you have in the problem and combining everything together.